Hey everyone, let's talk about shader layers a bit. So for those of you who uh, have used Shadertoy or are familiar with programming shaders, this might be a bit simpler. For those who don't, go and check Shadertoy and you can learn from a lot of examples, or you can start here and use the examples in Shadertoy, as I will show in this small tutorial. So shader layers are based on the Shadertoy idea, except that they work at different stages in the rendering pipeline of Clavicula. And so, for instance, pre-opaque go before anything that's in the scene gets rendered. The post-opaque afterwards. The post-composite after the compositing of the image is done. Of the scene is done, and the compositing is actually the final result of depending on the rendering type. So for instance here the composite is what actually does the shows the material appearance and all that. For this one, for the normals, is it assigns some color depending on the normal coordinates. So yeah, let's go back to this one, and these are a bit different than the two last ones, and for a certain reason I'm gonna just show you the differences. So this is how a shader layer looks like. You have a bunch of things here, but I'll explain them a bit later. This is the compile result. You don't have anything here, so right now there's no compile result. This is auto-compile, so that means that when you write code, you'll have automatic compilation results here. You can turn this off and just compile hitting this one every time you want to compile, but I'm going to leave the auto-compile on. You can create a new shader layer. So this is the bare bones main function of a fragment shader. And you can open and save as XML or GLSL files, save, and yeah, a bunch of other stuff. And this actually runs the shader. These are the textures that you can use. It's like the channels in Shadertoy, and these are loaded as uniforms here. So this is the input-output code, and you see that we have access to a bunch of things. All the things that start with I are input. So some input textures, you have some noise, the cube map that is used for PBR rendering, and a lot of other all these channels are actually coming from the rendering side of the scene, and all the things that start with an O are output, and these need to be written. So as I said, the first pre-opaque and post-opaque stages are a bit more complex to write. As you've seen, we have to write a bunch of things, and we also need to write some of them, all these material PBR material stuff only if the rendering is PBR. So yeah, that's why the if-def exists here. But I'm not gonna look over these ones since they are a bit more complex. Instead, let's do let's say a post-composit shader layer. So yeah, this creates a new shader layer, this opens one, this turns all the stage on off, and this is the actual shader layer. You can turn it on here or off. Here you see, if you have code, you see the two dots, and if it compiles okay, it's green. So let's look over this one. So already the input code is a lot, input-output code is a lot simpler. We only have to write one color. So it's a vector 4, RGB, and alpha. And yeah, let's start with a very simple stuff. Let's just make it all black. So black is 0, compile is okay, turn it on, it's all black. No matter what's in the scene, it turned all black. As you can see here, we have the some stencil options, and there are actually a bunch of options, as you can see. So first of all is writing over everything. So that's what stencil all means. It means that this code will be applied for each of the pixels on the screen. I can apply it over the background, and all of a sudden it only colors the background. And I can also apply it to the content. Content is actually layer plus scene, and the scene is the geometry that you have in the scene, and the layer is what is created by these two stages in the shader layer. But yeah, let's not go into too much detail. For now, I'm just coloring the background black. Okay, so let's do something a bit more complex. So you see, every time you have an error, even if this tells to run, you have the error here in red, and the shader is actually disabled, although the run is on. So what I'm gonna do is let's take the coordinate on the screen. So this is OpenGL shader layer syntax, shader syntax, so you can search for that on the internet. So the XY are the coordinates on the screen. This is 0, 0, and this is the resolution on X and Y. So if I do this and this, you will see that this is completely yellow, except for like a line here and here. So what I have to do in order to bring it in the range of 0 and 1, I divide by the resolution, the input resolution of the screen. And let's put XY, although it's a vector 2, but I don't know, maybe in the future I'll add also the depth that is actually set in I set in OpenGL. So what does this mean? It means that we start here, and red is the X. So the further I go on X, the red becomes brighter, and the further I go on Y, the green becomes brighter. So yeah. Let's put here the time. So you have the I time, the input time, and I'm gonna do a sine of input time, and let me bring it, so this is between -1 and 1, and let me bring it to 0, 1. So now you will see a pulsating blue component. If I multiply this with 0, you'll have only the blue component pulsating, and let's increase the speed. So yeah, let's put back the red and green, and let's dial it down a bit. Yeah, let's keep it like this. So yeah, that's a simple thing. If, for instance, you just want to get the color, the initial color, so okay, texel fetch. So all these samplers, all these textures that represent the values on the previous stage of the shader, and this is the main difference to Shadertoy. Here you can only you always apply a shader layer to the previous stage, so you have access to the previous stage. You don't have access to other, for instance, from this stage you won't have access to the pre-opaque stage. You only have access to the post-composite stage, and namely the shader layer that's right before the current edited shader layer. So yeah, that's a bit more restrictive than Shadertoy on this, but I will add the possibility to have some custom shader layers with custom texture size. Okay, so I was saying now I'm gonna read the previous image, and I have to transform the frag coordinates to an integer vector 2 and LOD 0, and just like in C, I can comment this. So from here on end, it's a comment. So what this does is it just takes the previous value of the image and it outputs it to the output. So it's just copying the previous image to the new image. This doesn't do much, but I can, for instance, multiply with 2. This means that I'm making it brighter. So it's the previous image made brighter. If I want to do some gamma correction, I can do power color 2.2 or 1 over 2.2, something like this, or I can do color correction 01, 02, 03, and yeah, let's keep this to 1. So this is, yeah, color correction, color balance, but in written as gamma per color channel. Okay, and I can do this again for the content, for the background, both. And scene is, in this case, the same thing as the content. Okay. Next, let's try to adapt something from Shadertoy to see the correspondence between different variables and outputs. And yeah, so I have here this shader by Nimitz, and I have used it in a previous post as a background for the astronaut. So let's see how this can be used in as a shader layer. Okay, so most of Shadertoy layers, I mean, they can be used at any stage, but the easiest for a direct copy is to use them in these two final ones. So yeah, let's start easy, because otherwise it might get a bit complicated. But as you'll see, this stage actually brings some really great stuff, because for instance, for SDF functions, if you create them here, you will have the rendering pipeline of Clavicula who will take care of the rest. So you don't have to actually render, you just have to put stuff in the depth and normal buffers. So just have to write depth and normal. And color if you're in this mode. Color and material properties. Okay, let's go back to this one. As I said, I'm gonna create one shader layer here in Post-Composit, and I don't care about this. And let's take, so this is the whole code, and we see that we also have a noise texture, so I'm gonna just copy it all. Okay. And yeah, so first thing, there's no channel 0. These are called iText 0. Well, this is, yeah, not really done to mess things up with the way Shadertoy is done. It's more of a specific thing to Clavicula. Yeah, even this one is just one convention, so it's not some standard. I kept it like this because, yeah, it was more compact, and I needed the compactness when we do stuff more on smaller screens and all that. So yeah, but the channel, the texture in channel 0 is actually the noise. So what I can do is I can use the iNoise here, which is a 512 by 512 noise texture, and it's RGBA, so it's not just gray texture. So you can use, and you can use either channel of that texture in here. So let's apply this to the background. Right now it's not working, so no problem there. Let's replace this with noise. Okay. So the error is no longer this one. It's complaining now that fragment info, no program defined. Why no program is defined? Because in Shadertoy you have this as the main function. Behind the scenes, it's probably it's a main function with which is using this one, but never mind. In order to properly adapt it, you need to rename this to main. So this is the OpenGL, the GL shading language standard, and you don't have this. So one easy way to do is I'm gonna comment these, and what I will do, we can define frag color to be the frag, no, sorry, this is the output color, and the frag coordinates, frag coord is actually the GL frag coord dot xy, which is actually the convention in the shading language. Okay, so now it's compiling okay. You can also just take these and replace them here with this. Let's see if it needs to be done anywhere else. No. And replace this here as well. And it works. I'm gonna erase this as well. And now let's see what happens. I'm gonna turn it on. So yeah, it's a bit weird, but we get the same, at least the same color palette. And I think the issue here is the scale. So yeah, the main reason I removed this one because it's not used. The main reason this happens is because the noise texture here is 256 by 256, and you can probably see it in here in textures. Yeah, it's 256 by 256, and the one in Clavicula is 512 square. So I'm gonna have to divide this by 2, so 0.5, and there you have it. You have this one just does what you see here inside the on the background, and again we can expand it to everything or just put it on the content. But let's keep it in the background for now. So yeah, if you want to add some texture, let me just go and yeah, let's create a new one. Oops, yeah, I think it had the tool selected and it added something in the scene after it lost focus. Anyway, let's write some code. Let's cover the sphere with blend with some other texture, or let's blend everything. I'm gonna load, oops, yeah, let's take some image. Let's take an animated image, this one, I guess. So this is an animated GIF, or whatever you call it. And let's write the code. So once you have this one, it already shows in the hint for the textures if they are collapsed, and it also appeared here in the IO code. So it's a sampler, it's a uniform sampler, and it's called itex0 as here. So I have to write output color. Let's define the input color, and I'm gonna take let's start by the coordinates. UV equals, so I take the normalized coordinates on the screen divided by the resolution. Okay, I'm going to use directly the texture to take the eye image UV. So this is the input color. If I do this, it's exactly a copy of the input image, but let's mix it with the texture. And I'm gonna stretch it over the whole screen, and I read from it just like from the previous texture, except that this one is actually a 3D sampler, so I put the time in so that I get a different frame at each rendering. As you can see, it's a sampler 3D, but you can also load 2D images here. And now if I write this, I output directly the animated GIF as an animated output on the screen. If I want to mix it with the previous, let's do this, and 0.5. So I just overlap it over the previous image. If I do it over the background, I can also do it over the content. And yeah, there we have a interesting way of working with shaders. And let's say, as I said, one of the advantages of shader layers, so you can turn them off and on. One of the advantages of the shader layers over the Shadertoy framework is that you can actually create some geometry in the scene, and you can apply the shader layers over the geometry. So if you have very complicated objects that you want to create, you don't need to create them using SDF functions. You actually have import options, or you can model them inside Clavicula. And that's one of the things. The other is that you can you have access to outside textures, so you can use them for even texturing or doing some weird stuff with noise or with animations or everything like that. And the other part that's interesting is that you can profit from Clavicula's rendering pipeline. So for instance, right now, if I change to PBR, why did everything change? Because these post-process effects are applied after the post-composit section and before the final. And final is applied on top of everything. So in PBR you have the gamma, which is 2.2, so you can go to 1. You have a tone map, and I believe that's it. So right now, if I change back to all these that don't have the PPR post-process function, it should look almost the same, but it's not the same, and it's probably something that I still forgot. But no matter. Oh yeah, it's the actual color on the object, which looks like this in matcap rendering and looks like this in PBR. So here you can see the material. Yeah, so that's pretty much it for this introductory tutorial on shader layers. I've spoken mostly about these ones, but in the next tutorial I will show you how to use the pre-opaque to create SDF geometry using SDF functions, and also how to use the post-opaque stage in order to compute the normals directly from the screen. And once you have these, you only need to, for instance, play with the SDF functions. The rest will be calculated here, and it will be, the rendering will be done according to the classical Clavicula's rendering pipeline. So that's one advantage. The disadvantage of shader layers over Shadertoy is the fact that you don't have these buffers in which you can, but you also don't really have to depend on the previous stage. So these are all separate buffers in which you can do other computations compared to Clavicula, where you always the input is from the previous stage. So all the eye image, eye depth, eye normal are from the previous rendering stage in the pipeline. So yeah, that's it for now. See you next time.